Hey there, welcome to Tech World GBA, your go-to channel for all things tech. If you love staying updated with the latest in technology, gadgets, and tutorials, you're in the right place. Today, we will dive into theoretical concepts of React hooks. Welcome to the exciting world of React.js, a powerful JavaScript library for building dynamic and interactive user interfaces. In the ever-evolving landscape of web development, React has emerged as a dominant force, captivating developers with its component-based architecture and efficient rendering capabilities. With React, you can break down complex user interfaces into smaller, reusable chunks called components. Imagine building a website like a Lego masterpiece. Each Lego brick represents a component, and you can assemble these components to create intricate and engaging layouts. React's declarative style allows you to describe how your UI should look at any given point in time, and the library takes care of updating the actual DOM, or document object model, efficiently. This component-based approach not only promotes code reusability but also makes your code base more organized and maintainable. As your application grows in complexity, React's component structure helps you keep things manageable and prevents your code from becoming a tangled mess. However, like any powerful tool, React has evolved over time. In the early days, developers primarily relied on class components to manage state and lifecycle methods. While class components served their purpose, they could sometimes feel cumbersome and verbose, especially for beginners. Enter React hooks, a game-changing addition to React 16.8 that revolutionized the way we write React components. Hooks are functions that allow you to hook into React state and lifecycle features from functional components. This means you can now build powerful and stateful components without writing a single class. Hooks empower you to write more concise, readable, and maintainable code. They achieve this by providing a more direct and intuitive way to manage state, side effects, and other React features. With hooks, you can extract and reuse stateful logic more easily, making your components more modular and testable. Before hooks, if you wanted to manage state or use lifecycle methods in a component, you had to write a class component. This often resulted in components that were unnecessarily complex, especially for simple tasks. Hooks simplify this process by allowing you to use state and other React features directly within your functional components. Think of hooks as special functions that act like superpowers for your functional components. Each hook has a specific purpose and provides a way to tap into React's internal mechanisms without the need for classes. This makes your code cleaner, more efficient, and easier to reason about. Why are hooks such a big deal in the React world? They bring numerous advantages that significantly enhance the developer experience and improve code quality. One of the most significant benefits is improved code readability and conciseness. With hooks, you can express complex logic in a more straightforward manner, making your code easier to understand and maintain. This is particularly beneficial when working on large projects or collaborating with other developers. Hooks also promote code reuse through custom hooks. You can extract common stateful logic into reusable functions, making your components more modular and your codebase more organized. This modularity not only improves code organization but also makes testing and debugging easier. By breaking down your logic into smaller, reusable units, you can isolate and test specific parts of your application more effectively. In essence, hooks empower you to write cleaner, more efficient, and more maintainable React code, making your development experience smoother and more enjoyable. In the upcoming sections, we will delve deeper into each of the primary hooks, exploring their functionalities and demonstrating their practical applications through illustrative examples. In React.js, state management is key to dynamic user interfaces. Hooks revolutionize this by bringing state management to functional components. Imagine building a simple counter app. The hook lets you declare state within functional components. This makes your code more organized and easier to manage. It empowers you to create dynamic, responsive UIs effortlessly. Section 2, Deconstructing useState syntax and structure. Let's break down the syntax and structure of the useState hook. You provide an initial state value as an argument. This value can be a number, string, object, or array. This line declares a state variable and initializes it. The square brackets represent array destructuring. The first variable holds the current state value. The second variable updates the state. Understanding this syntax is crucial for using useState in React. Section 3. useState in action. A practical example. Let's bring to life with a practical example that demonstrates its power and simplicity. Imagine you're building a to-do list application. You need a way to store the list of to-do items and update it whenever the user adds or removes an item. You can achieve this seamlessly. In this example, we initialize our state using creating an empty array called to store our to-do items. The function handles adding new to-dos to our list. Inside this function, we use to update our state. Importantly, we use a callback function within to access the previous array, ensuring we don't mutate the state directly. We use the spread syntax to create a new array containing all the existing to-dos and then add them to the end. This approach ensures that React detects the state change and updates the UI accordingly. This example demonstrates how effortlessly handles dynamic updates in a React application. As the user adds to-do items, the UI seamlessly reflects those changes thanks to React's efficient rendering mechanism triggered by state updates. This simple yet powerful example showcases how it can bring dynamic behavior to your React components, making them interactive and user-friendly. Section 1. Introducing useEffect, the side effect maestro. In React.js, functional components shine for their conciseness and readability. But managing side effects like fetching data or setting timers requires useEffect. useEffect acts as a bridge, handling tasks outside the rendering process. It ensures operations occur at the right time without disrupting UI rendering. Section 2. Deciphering useEffect syntax and behavior. Let's delve into the syntax and behavior of useEffect. It accepts a callback function and an optional dependency array. The callback defines the side effect. React executes it after each render. The dependency array controls execution frequency. Pass an empty array to run once. Omit it to run after every render. Use specific values for precise control. Mastering this optimizes performance. Section 3. useEffect in practice, fetching data. One of the most common use cases is fetching data from an API. Let's imagine you're building a user profile component that displays details fetched from an external API. You can seamlessly integrate this data fetching logic into your functional component. Import React, useState, useEffect from React, function user profile, user id, const user set user =useState null, useEffect const fetch data async const response await fetch const data await response.json set user data fetch data user id / run only when user id changes if user return loading return user.name user.email. In this example, we have a component that receives a prop. Inside we define an asynchronous function to fetch user details from the API. We use the API to make the request and update our state once the data is available. Notice the dependency array. This ensures that our runs only when the prop changes. If the component re-renders with the same, the effect will not run, preventing unnecessary API calls. This example highlights how elegantly handles asynchronous operations like data fetching. It keeps our component logic clean and efficient, ensuring that we fetch data only when needed and update the UI accordingly. The strategic use of the dependency array is key to optimizing performance and creating a responsive user experience. Section 1. Use context, sharing data across components. In the realm of React.js, building complex and dynamic user interfaces often involves sharing data across multiple components. While passing props down the component tree is a common approach, it can become cumbersome and inefficient as your application grows, especially when dealing with data that needs to be accessible by components deeply nested within the hierarchy. Imagine you're building an e-commerce application with a theme switcher. The user's theme preference needs to be accessible by various components, such as the header, product listings, and the shopping cart. Passing this theme prop down through multiple levels of components would quickly clutter your code and make it harder to maintain. This is where React's Context API, coupled with the hook, comes to the rescue. The Context API provides a way to share data globally within a React application, allowing components to access the data they need without relying on prop drilling. Think of it as creating a shared data store that any component can tap into, regardless of its position in the component tree. Acts as the key to unlock this shared data store. It allows your components to subscribe to context changes and access the latest context value with ease. This eliminates the need to pass props through intermediate components, making your code cleaner, more efficient, and easier to manage. Section 2. The Context API and useContext, a powerful duo. Create a context using which returns a context object with, and hook provides a concise way to access context values, replacing the need for the component. Section 3. useContext in action, a theme switcher. Create a component to wrap your application, providing access to the theme context. Used to switch themes and apply styles based on the context value. Section 1. useRef, beyond direct DOM manipulation. Creates references to DOM elements within functional components. It can store any mutable value across renders without triggering re-renders. Section 2. useRef in action, focusing an input field. Used to create a ref and attach it to an input element. Utilized to focus the input field after the component renders. Section 3. Persisting values with useRef. Can persist values across renders without triggering re-renders. Use it to store previous values or information essential for your component's logic. Section 1. Unveiling useMemo, a performance booster. Memoizes the results of expensive computations, preventing unnecessary recomputations. It significantly improves performance, especially with complex computations or frequent re-renders. Section 2. useMemo in action, optimizing expensive calculations. Used to wrap expensive calculations like generating Fibonacci numbers. The dependency array ensures recalculations only when necessary, optimizing performance. Section 3. useCallback, memoizing functions for efficiency. Memoizes functions, maintaining referential equality between renders. This prevents unnecessary re-renders of child components, optimizing performance. Section 1. Embracing the hook revolution. Hooks simplify state management, streamline side effects, and enhance component communication. They promote cleaner, more concise, and more efficient code. Section 2. Hooks in the real world. Where to use them. Hooks are versatile, used in various applications from to-do lists to complex data dashboards. They manage complexities efficiently, promoting code reuse and maintainability. Section 3. Unlocking React's full potential. Hooks have revolutionized React development, enabling cleaner code and improved performance. Continuous learning and experimentation are key to mastering React and building ambitious applications. Don't forget to subscribe to the channel and hit the notification bell so you never miss out on any of our informative videos. And if you enjoyed this video, make sure to like, share, and leave a comment below. We'd love to hear from you.